For this video, we're finding solids where the base of the solid is the area bound by y equals the square root of x equals 4, and y equals 0. The first one we're going to do is the solid is going to have cross sections that are squares, and they're going to be perpendicular to the x-axis. So this line could represent the side of one of the squares, and the squares will be very, very small down to 0 up to this height here. So one of the first things you want to actually find is, what would that look like? Like, how big is this, if you're wondering what it looked like? Well, if I look at the function y equals square root of x, the square root of 4 is 2, so this length is 2. So the side length, the biggest square could get is 2, so it would be 2 up, 2 over, and 2 down. But the way we do this, we're going to integrate our area formula, which is s squared. So I will integrate a side length squared, and this one is with respect to x, because I said the cross sections will be perpendicular to the x-axis. So that means that since this is a dx, I will start adding my areas here and end here to get my volume. So my limits of integration will be 0 to 4. The more positive function is the square root of x, and the less positive function is y equals 0. So this one, if I simplified it, would be the integral from 0 to 4. The square root of x minus 0 is just the square root of x. Squared is just an x with respect to x. So that's a pretty simple problem. For semicircles, the formula for area is 1/2 pi r squared. So I'll have a pi over 2 on the outside. And then I'm going to integrate my radius squared, and this is also with respect to x. More positive minus less positive, while it's the side length of the square, is actually the diameter if a semicircle came up. So for the radius, I'll do square root of x minus 0 divide by 2 squared. Same limits of integration, 0 to 4. And if I simplified this, the square root of x minus 0 is just the square root of x. When I square it, I'm just left with an x. The 2 squared in the denominator is 4. I can bring it out as a pi over 8. The integral from 0 to 4 with respect to x. And this is because it's a 1/4 here times a pi over 2 is pi over 8. If it was a rectangle that has a height 5 times the width of the base, I know that area equals base times height. The height is 5 times the length of the base, so this comes out to a 5b squared. So for this one, I'll integrate from 0 to 4. The 5 would be outside the integral. I'll have the base square it with respect to x, and the square root of x minus 0 is it's the base of the actual rectangle. So this one would be square root of x minus 0 is the square root of x. Squared is just an x, so you would integrate 5 times the integral from 0 to 4 of x with respect to x.